Number of chocolate chips in an 18-ounce bag. It's approximately normally distributed with a mean of 1,252 chips and a standard deviation of 125. It's a probability between 1,100 and 1,400. So you can't see it, but I see a dash T here. You use the TI-84's normal CDF under second bars or distributions. We'll go from 1,100 to 1,400. The mean was 1,252, and the standard deviation was 129. We want this to 4 decimal places, i.e. the 10,000th place. Those of you taking a class with me, remember I asked you to show what command you put in, what you've put in there for parameters, etc., in what order, and all that good stuff. So I'd want to see the after normal CDF, those 4 things. And then this to 4 places will be 0.7550. Now, before we go to the next part, our z-scores, because we had a mean of 1,252 and a standard deviation of 129. Our x's are going from 1,100 to 1,400. The z-score on the left, score minus mean, x minus mu, divided by the sigma, standard deviation of 129. When using the table, that's going to have to be rounded to negative 1.18. And from the table, just a moment. Here's our shading so far. Our parallel tracking of raw scores X, the number of chocolate chips, versus the Z scores. I still have to come up with, for the X being 1,400, what Z will equal. So I'll bring that up in just a moment while you're looking at that. So 1,400, 1,100. That's going to round to 1.15. Okay. So going to the table. The one on the left, when X is, sorry, when Z is negative 1.18. You can't see the 0.08 at the top, but that's just before 0.09. So here's our negative 1.1 row. This is negative 1.19. This is negative 1.18. That is 9 here. 0, 1, 2, 3, 4, 5, 6, 7. Right here. Do you have a 0.00? Two. Oh, it's 0.1190, but that's outside. And when we look up positive 1.15, zero, 1, 2, 3, 4, 5, that should be the 0.8749. Yep, that's in the 0.05 column. That's all the way to the left. So in the table approach, you need Z first, and then readings from the table go back to the left. You may need to think a little bit harder in cases about in between or outside of 2 scores, or if it is 1 score, but it's to the right instead of the left. The table is set up for the left. I'm going to subtract these 2 to take away that extra unshaded part. we'll see how that compares to what we got from the TI-84. Take away this extra unshaded part with an area of 0.1190. Like that would be 0.7559. What we came up with from the TI-84 was as follows. That rounded to 0.7550. So this is 9/10,000ths difference. That's kind of a bigger difference, but 9/10,000ths overall, that's pretty small. Okay, the probability of randomly selecting a bag containing fewer than 1,000 chocolate chips. Well, calculator approach. That 1,000 is an upper bound. It keeps going back to the left. So we need to put in negative 10 to the 99 as our substitute for negative infinity. Change this to 1,000. Same mean and standard deviation. So that rounding to 0.0254. Table approach, we need Z first. I did not need to know Z when using normal CDF, but we're looking at X less than 1,000. So Z less than approximately negative 1.25. I better see something pretty similar to what I just typed in there when I go to negative 1.95. Right. Oh, that's the positives. We want to go to the negatives page. So negative 0.195. 0, 1, 2, 3, 4, 5, 0.0256. And how does that compare? 256. Pretty close. 3/10,000ths away. All right, let's see what's in the next part. Containing more than 1,200. Now the mean is 1,252, and we're going to be going to the right of that. So I expect more than 0.5 with this. 1,200. And we want everything to the right shaded. That should tell us that we're putting in, if we use normal CDF on the TI-84, a finite lower bound, but it keeps on going to the right towards infinity. So we'll have to put in positive 10 to the 99 for our upper bound. Let's get out of there. $1,200 for lower bound. Upper bound 10 to the 99. Mean and standard deviation have not changed. That is bigger than 0.5 to 4 places. I'm sure that's where they still want it. Yes. That's going to round up to 0.6566. Our approach using z-scores and tables. U and sigma have not changed, but change x to 1,200. You're going to look up negative 0.40 on the table, but it's going to the right. So you could apply symmetry and look up positive 0.40 to the left of that. That's 0.6554, which matches pretty nicely with this. If we looked up the negative 0.4, we'd have to do the complement. So negative 0.4, we'd be doing 1 minus 0.3446. .6554, which again is only 2 10,000ths away from what we got on the TI-84. And then our last part, what is the percentile rank of a bag that contains 1,425 chips? I'm just going to show this on the TI-84. This is just a fancy way of saying what percent are less. So if I put in 1425 here, sorry, let's go left of that. So no finite lower bound, head towards negative infinity. Closest we can get is negative 10 to the 99. Go up to the stopping point of 1400, 1425, that is. Same mean and standard deviation. Convert that to a percent, 91.0 something. So we'd say that it's in the 91st percentile. All right, moving on. One more example I need to film.